Okay. Well, welcome to the poster fast forward session. We have four poster presentations today, and three of them will be live with our poster authors. And one of them is pre-recorded because the poster author was unable to make it here due to travel issues. So afterwards, well, the poster authors will also be at the individual posters, so you can ask them questions about their presentation after a brief summary. And hopefully, we had success with this earlier today. The one poster author will also be able to join us remotely via Zoom call, so I'll have a laptop there, and you can talk to that person and ask questions as well. As a short reminder, there's the best poster voting. So after the fast forward completes, please grab one of these red ballot papers that Mauricio is holding up from the front here. Fill in your choices for best poster and runner-up, and then hand them back to one of the committee members. If you keep the poster ballot, we'll not be able to count it. With that said, let's start with the poster fast forward. And first one is here. Just as a reminder, there's a lot of cables on the floor, so try not to trip.
Good afternoon, everyone. My name is Daiki Chihara from Tokai University. Today, I will talk about real-world appearance visualization using a multi-screen projection system and pre-filtered environment map. Wouldn't it be interesting if we enable to change the appearance of just one object to various other appearances? For example, it could be plastic, glass, or wood may also be possible. Our study is the first step toward achieving this. These are the results of applying our method. The yellow areas where our system has been applied look different, despite both are the same objects. This study aims to do in the real world what computer graphics can easily do. Please visit our poster. Thank you.
Okay, next one.
Hello, excuse me, Ashton Corsello. I'm HoloXR. It's a cutting-edge tool for advancing education research. So HoloXR is a joint collaboration between the Computer Science and Education Department at Kent State University. We are researching and developing new methods and techniques to study pedagogy. The Education Department is focusing primarily on two separate things. First is professional noticing, which is a teacher's ability to understand and identify and react to various classroom situations and activities. The second, which this application mainly supports, is undergraduate teaching and studying. With this application, a researcher will have the ability to study a teacher's ability to gauge a student's reasoning abilities and grade level. How are we doing this? With holograms, by displaying pre-recorded holograms in various levels of immersion, we are able to place several subjects in identical classroom situations and a single subject in the same classroom situation multiple times. These varying levels of immersion are very important so the user can have a more realistic environment, which provides more realistic data to the researcher. And the repeatability is important because you want to be able to minimize the differences between each user and session. Custom scenes as well. With the holograms, researchers have the ability to design their own custom scenes to best suit their own needs. So the main goal of this application is to push the boundaries between extended reality and education in order to utilize this developing technology in order to push it into new sectors. Thank you.
Oh, hello, my name is Jae-yoon Kim from KAIST, and I will briefly talk about our work, deep reinforcement learning based continuous adaptive radiance field sampling. And this is an overview of our reinforcement learning based adaptive radiance field sampling method. So we used the DTPG method to estimate the sampling maps for the radiance field sampling. So first, we pre-trained the denoiser for the real generator, and then we trained the sampling map estimator with the reinforcement learning method. And this is the network architecture for denoising and estimating sampling maps, and this is network architecture for evaluating our sampling map policies. And thank you for listening, and see you in the post session.
Okay, this gets us to the last poster, lightweight 3D viewer, real-time rendering of multi-scale 3D surface models by Ryun Lee. And well, there's a pre-recorded presentation.
Are you tired with the long loading time of 3D models and the difficulty of real-time interaction during the visualization? Our lightweight 3D viewer might be a solution for you. With efficient HLOD construction and real-time rendering, our viewer can handle massive 3D models with ease, while minimizing the wait time and realizing the real-time rendering with optimal visual quality. Our HLOD construction implementation, starting from standard mesh file formats, achieves competitive levels of the order of 1 million input triangles per second per core. Now I will showcase some real-time rendering results on different models. Here is the real-time rendering result of the LOD-colored Jungfrau region, where there are no mesh cracks between different LODs caused by different resolutions. Now you are seeing the wireframe rendering mode of Locarno terrain region, where you can see the process of vertex interpolation. This is the real-time rendering result of Egyptian temple wall paintings on a desktop computer with integrated graphics card, which have multiple texture images. Now, we are showing you the rendering result of David on a computer with a discrete graphics card, which can achieve better interactivity. And finally, the rendering result for St. Matthew. Thank you for listening to our fast-forward introduction of the 3D viewer. I'm sorry that I won't be able to attend in person today, but I will be available on Zoom to answer any questions you may have. If you have any thoughts or questions, please let me know.
So, well, first reminder, don't forget to vote for the best poster. And I think there are also some snacks and coffee in the back area, so grab something, talk to the poster people, and see you later tonight.